Welcome, my friends, to the Bob and Brad podcast. My name is Mike Keenitz, and today I'm interviewing Professor Russel Foster, who is a renowned neuroscientist and professor of circadian neuroscience at the University of Oxford. Today, we are going to be discussing the circadian rhythm and its effect on your sleep. So without further ado, here's Russell. Well, welcome to the podcast, Russell. Thank you so much for joining us today.
Really delighted to join you, Mike.
We already talked about it for our listeners that are watching. We do realize Russell is in black and white. He is not stuck in the 1930s, though. He assured me this. So can you share a bit about your background information and how you became interested in the circadian neuroscience and sleep research?
Well, yeah, I suppose I've got a slightly unconventional history. I was in remedial classes at school, living my own little bubble, and then sort of emerged because I just loved biology. I mean, I just found biology fantastic. And so when I could just study biology, I did really well. Then went to university thinking I'd become a marine biologist because I was a really good competitive swimmer. So I love biology, love swimming. Therefore, I was going to become a marine biologist. Then I discovered physiology in my sort of second year, and particularly the labs which examined light responses from animals. I remember the first sort of recording from the eye of a locust and the fact that you could actually record the light responses from this eye. I thought that was just so cool. And then that sort of got me into the regulation of biological clocks by light. So we have this internal clock, and I'm sure we'll talk about it more, but for it to be of any adaptive value, it has to be set to the external world. The classic mismatch between internal time and the external world is jet lag. And we eventually get over jet lag as a result of exposure to light in the new time zone. And I became obsessed with how the heck does that happen in not only mammals like us, but in other groups of organisms. And so that was the way in. And that's how I've been studying. And a big chunk of what I've done has been the fundamental mechanisms of how light regulates circadian systems and sleep. But later, I started to be interested in human circadian rhythms and human sleep-wake behavior because of a casual conversation in an elevator with a psychiatrist who said to me, "Oh, well, you study sleep, don't you?" And I said, "Yeah, kind of." And he said, "Well, my patients with schizophrenia don't have a job, so they get up late, go to bed late, miss my clinic, and don't have friends." And I thought that was one of the most stupid things I've ever heard. The man will remain nameless. And that actually triggered an interest. So we started working with another psychiatrist to actually measure empirically the sleep-wake patterns of unemployed individuals, individuals with a diagnosis, and age-matched working individuals. And what became so clear, and I can, as I speak, I see the data in my mind. The sleep-wake patterns of the individuals with a diagnosis of schizophrenia were smashed. They were the worst sleep-wake patterns I've ever seen. And so that got me into the sort of human side of things and studying circadian rhythms and sleep in a range of different subjects, and then sort of bringing the fundamental science together with the translational human and medical science. And actually, part of the move to Oxford, which is now approaching 20 years ago, was because I wanted to work with my clinical colleagues to translate the fundamental science into application in the clinic.
That's an interesting experience. We have schizophrenics to thank for your advancements in this field, huh?
Well, I mean, I think I actively didn't want to do medicine. I wanted to do biological sciences. I find if I had to do the things that doctors do, and we've got 3 kids, and 2 of them are either almost there or halfway there, and what they're going to have to experience and deal with, I couldn't. And so I suppose I was a coward and ran away from it. So I'm behind the curtain doing this stuff rather than front of stage.
Well, sometimes it's fun to be back there.
Yeah, I'm very comfortable back there.
So you've written 5 books, and in 2022, you wrote your most recent release titled Lifetime, Your Body Clock and Its Essential Roles in Good Health and Sleep. So what is this book about?
What part of the motivation for the book was I wanted to outline the science, the evidence base our current understanding of circadian rhythms and sleep, and then how we can use that information individually to enhance our sleep circadian rhythms, our circadian health. Why? Well, I think there's a lot of interest in this. There's a lot of misinformation, and I suppose I was kicking against some of the rather strident comments that you must do this, you can't do that, and I thought that was just a bit frustrating. You must get 8 hours of sleep. You can't look at a Kindle before you go to sleep. So I sort of unpack the science and then let people choose for themselves. I mean, it really is important to appreciate that healthy sleep duration can be as low as 6 hours, and it can be up to 10 hours. And what we all have to do as individuals is define what our sleep needs are and our sleep pattern. And as much as possible, within all the demands of the real world, is to then stick to that kind of pattern and not be frightened by, you've got to do this, you've got to do that, you've got to listen to your app. We're in a fantastic position to appreciate whether we're getting the sleep we need. We don't need a half-assed, device to tell us. And I suppose that was part of the motivation. And it's just amazing biology. I mean, whenever you go to a dinner or you sit next to somebody on a plane, you start talking about circadian rhythms, and they all get excited about it. So at least they pretend to be. And so I thought it would be good to sort of put down the science and some of my ideas about the science as well.
So where can people find this book if they want to order it?
Well, it's available all over. All the book retailers sell it. In the UK, it was actually a bestseller, both in hardback and softback, and has won some awards and stuff. So yeah, it's just Google it, and you'll find it. And Yale University Press are the American US publishers, so you'll see it under their banner as well.
So we're going to actually start talking about what circadian rhythms and sleep questions now. So what are circadian rhythms, and why are they important for our health and well-being?
If you think what about our biology's got to do, it's got to deliver the right stuff at the right concentration to the right tissues and organs at the right time of day. So there's a real time structure to our biology. And you could argue that this internal clock stops everything happening at once. Why do we need it? Well, we live on a planet that revolves once every 24 hours, and we have a light-dark cycle. And these are profoundly different environmental states. And we've evolved, as all life on Earth has evolved, to adapt to the varying demands. So, for example, in humans, in anticipation of sleep, our core body temperature will drop, our metabolic rate will drop, and we'll have the brain, of course, is very active while we sleep. It doesn't shut down. We're laying down memory, we're processing information, we're clearing toxins, so there's a lot going on. But then we need to gear up for physical activity. So before we even wake up, our metabolism is increasing, the release of glucose into the circulation, the stress hormones like cortisol are beginning to rise, core body temperature is going up in anticipation for increased activity later in the day. So when we finally do wake up and we get out there, our biology is prepared for activity. So what the clock can do, the circadian system can do, is fine tune our biology to these varying demands of the rest activity, the light-dark cycle. And it's of paramount importance, because without that fine-tuning and that anticipation, we'd have our biology just simply wouldn't be fit for purpose. And where experiments have been done where the clocks aren't working, in animals, for example, biology falls apart.
What? Yeah, because you have nocturnal animals. I'm assuming their circadian rhythm's a bit different.
Well, that's what's so cool, because the fundamental clock, and we can talk about the mechanisms that generate that clock, they're the same in a mouse, which is nocturnal, and in a human. It's so extraordinary. Patterns of gene expression go up and down in the same way as in mice and humans. It's downstream that the decision is made to be nocturnal or diurnal. And and we don't really, well, we certainly don't understand really where that switch is. And what makes a mouse nocturnal and us diurnal? I think it's a really fascinating question.
Yeah. So how do circadian rhythms influence our sleep-wake cycles?
Okay, so sleep-wake timing is driven by two critical biological processes. One is the circadian system, which is defining essentially when is the appropriate time to be awake and when is the appropriate time to be asleep. And it adjusts, the underpinning physiology, the switch from wake to sleep and sleep to wake appropriately. Because in a sense that sleep wake involves a complete realignment of all of the brain neurochemistry and so much of our biology. And so that timing is governed by the circadian system, but another factor too, which is what's perhaps the most intuitive part about sleep, which is sleep pressure. The longer you've been awake, the greater the need for sleep. And sleep pressure builds up from the moment we wake in the morning, and it can get to really quite high levels. But why don't we fall asleep in the middle of the afternoon? It's because the clock is saying, no, stay awake. Now is the appropriate time to be awake. So in a sense, the circadian drive for wakefulness is opposing that buildup of sleep pressure the longer we've been awake. And interestingly, just before we fall asleep, the circadian drive for wakefulness is at its highest. The clock then says, okay, time for sleep. The sleep pressure kicks in, you fall asleep, and the clock is not only saying don't be awake, it's stay asleep. And then as we're asleep, the sleep pressure dissipates, so that by the time we get to the morning, the sleep pressure is dissipated and the clock then starts to say, okay, time to wake up. So you've got these two fundamental mechanisms which are talking to each other. And we've been doing some work fairly recently showing that the sleep pressure and the circadian system are also talking to each other. So what's fascinating is that you sleep deprive a mouse, for example, and almost certainly a human too, the sensitivity of the clock to light is changed. So they're talking to each other in ways we don't fully understand. And that's, I think, one of the really exciting bits that are emerging. We know these processes exist, but how do they interact and how do they provide our sleep timing?
So does someone that like to nap a lot, do they have differences in their circadian rhythms, or what causes that?
Well, actually, that's really interesting. So what's happening, you can think of, is that we talked about that sleep pressure building up and up and up. Now, if it's building up faster than the clock is saying stay awake, you can feel tired in the middle of the afternoon. You have a nap, short nap, pushes back the sleep pressure, which means that you can feel better during the second half of the day. So short naps can be very effective. They do indicate you're probably not getting all the sleep that you need at night. So it's not something that you can necessarily think is a great idea. Occasional nap, no problem. But if the problem about napping is that it can drift. So we did some studies on teens, and we sort of saw that they were going to sleep very late. And we can talk about chronotype in a moment, but basically, social media and all that other stuff that had short nighttime sleep, waking up driven out of bed by their carers, parents, or whoever, chronically tired, so struggled through the school day, got home, then they'd have not a nap, but a 2 or 3 hour sleep, which then pushed back the sleep pressure, meaning it was much more difficult to get to sleep that night. So you can get into a vicious cycle of later or more and more restricted nighttime sleep, more tired during the first part of the day, nap, so longer naps, later sleep. So occasional short 20-minute nap is fine, but you've got to be careful it doesn't expand into a really unhelpful sleep pattern, meaning you can't function optimally during the day.
Yeah, unless I am sick or for some reason don't sleep well, which isn't very common for me, I rarely nap. I'm one of those people that just passes out for like 2 hours. When you go to nap, I can't do like a 10-minute nap. So I noticed that it just throws off my whole pattern.
Yeah, I mean, but it's all about, with your sleep habits, are you able to function optimally? Are you able to form at your peak when you need to? And if you do, then in a sense, you needn't worry about it. I mean, do you know if you're getting the sleep that you need? It's kind of grandparent wisdom. Are you able to function optimally during the day? Do you oversleep extensively on free days? At the weekend or when you go on holiday, for example? Are you dependent upon an alarm clock or something else to get you out of bed? Does it take a long time for you to wake up? Do you feel groggy? Do you feel sleepy, irritable, fatigued when you are awake? Do you crave a nap? Is your behavior overly impulsive? One of the great interesting things about tiredness is you do stupid and unreflective things. Do you crave caffeine, caffeinated drinks, sugar-rich drinks? And also, do your friends, family, and colleagues report that you're a bit more irritable? You're not showing the same empathy. You're being a bit disinhibited. So if it's none of those issues, then you're probably fine. And it goes back to the point we started with, which is sleep is very dynamic, it's very flexible. It's one shoe size does not fit all. You do what works best for you for your optimal performance.
So could you explain the role of light in regulating our circadian rhythm and how it impacts sleep patterns?
Mike, how long have you got?
A while.
Okay, so this is where I've spent a lot of my career. I've worked on non-mammalian vertebrates, so sort of amphibians and reptiles and birds. But a big chunk of what I've done is how does the eye detect the light-dark cycle to regulate the internal clock? Now, the thing that puzzled me, and I was fortunate enough to be taught by an extraordinary professor called John Lithgow, who wrote a book way back in the late 70s called The Ecology of Vision. And what he laid out beautifully is that sensory systems are adapted to particular sensory tasks. Now, when you say it like that, it's kind of, duh, yeah, well, obviously. We knew that the eye was required for the regulation of the internal clock in mammals. Different in other vertebrates, but mammals, the detection is only through the eye. But if you think about it, what we knew about the visual system, what the visual system needs to do is grab light, detect it, and then in a fraction of a second, forget it's seen it. It needs a rapid assessment of the light environment to make an image of our world. Now, the clock doesn't need vision. What it needs is the detection of relatively bright light at dawn and dusk over long periods of time. It needs to assess dawn and dusk. And that sensory task, of course, is light detection, but it's utterly different from vision. And so I couldn't really reconcile how the visual system could also be a good circadian light detector. And so what I started working on was in mice with hereditary retinal disorders, mice which were being studied to understand human eye disease. So their visual cells, the rods and cones, had broken down. And so these animals were visually blind. And we popped them in a running wheel, we exposed them to a light-dark cycle, and they aligned their circadian rhythms absolutely perfectly with a light-dark cycle. And not only could they do it, they did it with perfectly normal sensitivities. And at that point, we began to think, well, hang on, maybe there's something really interesting here. And I remember going to one of the big vision meetings, actually in the States, when I was based at the University of Virginia, where some of this early work was emerging, and said, so these data are consistent with perhaps there's another light sensor within the eye. And one person stood up towards the end of my talk and said to me, bullshit, and just walked out. I mean, there was incredible opposition to this. It's really interesting. And the central criticism was, look, we've been studying the eye for 150 years. Are you seriously telling us we've missed an entire class of light sensor? You know, God, the arrogance of this young pup. I had, I suppose, the confidence of youth, and sort of said yes, and I was confident about the data. But there was a weakness in the data, because there were still a few rods and cones, visual cells, left within these degenerate eyes. They weren't sufficient to see, but the argument was, could they be sufficient for regulation of the clock? And so we had to genetically engineer a mouse with no rods, no cones at all. And we made several models. And all of these rodless, coneless mice entrained absolutely beautifully with unattenuated sensitivities. And that led to the discovery of this third receptor system within the eye. And it's based upon the ganglion cells of the eye. So the optic nerve it arises from a bunch of ganglion cells, which you can think of as sort of the outer layer of the retina. They send their projections, their axons, into the brain. That's the optic nerve. And 1 out of every 100 of those ganglion cells is directly light sensitive. It has a specialized light sensitive molecule, a photopigment, that detects the dawn-dusk cycle and sends that information in to regulate the clock. And so that there is, the eye, if you like, is even more extraordinary than we think. It's giving us our sense of space through vision, but it's also giving us our sense of time, because it allows the internal clock to be set. Now, if you don't have your eyes, and we work with those individuals, and it really is, it's so debilitating, because these individuals don't have vision, but they also suffer essentially unremitting jet lag for the rest of their lives, because the clock is drifting through time. It can't lock on to a light dark cycle because those receptors in the eye have gone. And so what we've been working on recently is trying to understand exactly how those receptors, those photosensitive retinal ganglion cells, actually interact with a molecular clockwork, the master clock within the brain. And what we've got now is some drugs which mimic the effects of light on the clock, which is really exciting. We've done all the mouse work, we've done the preclinical work, we've done first in human, we know the drugs are safe. And so now we're building up sort of a war chest, a funding chest, to do the first clinical trials. And what we hope is that we can give back a sense of time to these time-blind individuals. And it's worth bearing in mind, I mean, just a brief anecdote, because I've worked closely with these extraordinary individuals, and this is Blind Veterans UK is one of the groups we work with. And these are fiercely independent individuals. And this chap told me the story that he was not going to have the unkept front yard, the front garden. And so he'd worked out a way to get the lawnmower out of the shed. He'd worked a way to cut the grass on, in front of the house. Couldn't see it, but he just wanted to make sure it was okay for everybody who was looking at it. And then his wife came down and tapped him on the shoulder, and she said, "It's 3 a.m. The neighbors are concerned." And that's, good. And you can just imagine, here's somebody, who wants to do something that's important for him, and yet he's completely undermined because he's got no sense of time. And so, and also you see, going back to our individuals with schizophrenia, they have their eyes, but their rhythms are smashed. And I think these drugs could be used very valuably in those individuals, because you can then set the clock and then, wean them off the drugs, and then get them onto a stable light dark cycle. So you can sort of consolidate, then move on. Also true, I think, for children with neurodevelopmental conditions. It's, as many people will be aware, that many of these kids have terrible sleep-wake patterns, and it not only disrupts them and their ability to interact with others, and not least their educational opportunities, but also the entire family. Maybe these drugs will be useful in stabilizing their sleep-wake, where very little can be done. Other areas, of course, dementia and Alzheimer's, where sleep-wake is completely shot in later stages. And I think, if we can stabilize those individuals, that will be really important too. So I think it's a great example where entirely curiosity-driven research. How does the eye detect light with a circadian system, from a completely sort of theoretical model, and isn't that cool type stuff, discovery of new receptors, which had been missed for well over 150 years, now to an application whereby we can, I think, improve the quality of life for many different patient groups.
So is the drug an oral application or eye drop, or what is it?
No, it's an oral application. And this, one of the drug that's most advanced is a repurposed drug, which means it was developed for something else. It didn't work, but what we have developed is a high throughput screen where we can look at literally hundreds of different compounds, look at their effect on the clock, and these are little clocks sitting in a dish. So how do those compounds interact with a molecular clockwork? And we've identified 5 different classes out of thousands that will shift the clock. And so this is the first one that we're developing. And I think because sleep-wake circadian rhythm disruption comes in so many different forms, the different drugs will attack different bits of the pathway. And so, for example, one of the other drugs will increase the amplitude of the clock, so produce more strongly driven circadian rhythms, which could be important, for example, as we age, where circadian rhythms begin to flatten out. Classic example that many of your listeners might be aware of is, of course, the need to get up at night and pee. The problem is that the drugs, the hormones underpinning urine production, which should be high during the day and low at night, become less clear. And so we're producing more urine at night. It's not just an enlarged prostate or other bladder problems. There are actually underlying circadian changes in our biology which don't allow such sharply defined rhythmicity.
Huh. It's interesting. I have to get up every night and go to the bathroom.
But you're still young.
Yeah, I drink too many fluids, probably.
There you go.
I'm blaming it on that. So how does artificial lighting and screen devices affect our sleep, and are there ways to minimize their impact?
I think this is an incredibly important question, and the details are unresolved. And this is a good example where there's some misinformation out there. So, for example, you'll hear, do not look at a Kindle before you go to bed. That's based upon a study which made people in the lab look at a Kindle for 4 hours before they went to sleep on 5 consecutive nights. And at the end of 5 nights, sleep onset was delayed by barely 10 minutes, and it was barely statistically significant. And that was then blown into looking at a Kindle before you go to bed will disrupt your circadian rhythms. And as one of my colleagues said when the data were presented, well, it may be statistically significant, but it's biologically meaningless. It's lost in the noise. And very importantly, later studies showed that if you get reasonable amounts of light during the day, those tiny effects are abolished. So if you keep people under relatively dim light, it looks as though the circadian system is sensitized to some degree and might just respond to the dim light from a Kindle. But if you're getting anywhere decent levels of light during the day, that effect is abolished. And so the problem that we face is that the circadian system can integrate light. And what I mean by that is that you can increase the intensity and decrease the duration, or you can decrease the duration and then increase the intensity. And so where people have reported, for example, that room light in the evening will shift the clock, yes, but you need 6 or 7 hours of light exposure to get that. And that's done within the lab under tightly controlled conditions. We don't know what it's like if you're getting normal, daytime light during the day. So we don't have any, as far as I'm concerned, we don't have any really good guidelines to say this amount of light is bad, this amount of light is fine. I think the rule of thumb would be to minimize bright light exposure. That makes sense. More of a worry for me is not necessarily the light from devices, but it's the alerting effect. So if you're working on a smartphone and you're doing your social media, you're doing your emails, you're doing all that kind of stuff, you're going to be alerting the brain, and that increased alertness would delay sleep onset. So we need better studies. So I was the specialist advisor, science advisor, for a parliamentary commission, actually, at the beginning of first 6 months of last year, looking at the impact of light and noise on human health, and particularly human sleep and circadian rhythms. And it was brilliant because we got to interview, large numbers of scientists from around the world, and then published a document, and we conceptualized all of these issues and the experiments that need to be done to provide these guidelines. You see out there saying, well, you shouldn't see more than 40 lux for the 2 hours before you're going to bed. Now that's really dim light. And if you're elderly and you're living in dim light conditions, you know, the chance of falls or trips or things, I think that's a greater risk. We also know that the clock is less sensitive as we get older. So you've got all these factors: the intensity, the duration, the color, how old you are, how much light, natural light you've experienced during the day. And we haven't a good model that's pulled all that together. So to try and answer your question, should we be worried about devices? I think I'm not overly concerned. I don't think there's that much light. I think we should be concerned that they do have an alerting effect, and there are nice studies on teenagers showing that they will delay sleep onset. It does make sense, though, to minimize bright light exposure in the evenings, and let me explain why. We've talked about the importance of light in regulating the clock, but light has different effects at different times of day. So morning light advances the clock, makes you get up earlier and go to bed earlier, but dusk light delays the clock, makes you go to bed later and get up later. So if you're seeing enough light to tickle the circadian system in the evening, yeah, you will shift your clock to a later time. And what values? Well, I guess it's not going to be much above 100 to 200 lux. I think you're probably safe, unless it's for very long durations.
Yeah, because many times I remember blue light, it was a big thing in the news, and they still have blue light glasses. Is that something you work with?
I've looked at the study, the studies. There's a Cochrane report on this, and there's no evidence that they have any effect at all. And this raises a really important point, Mike, because those photosensitive retinal ganglion cells are maximally sensitive to blue light, and it's the sort of blue that you'd see on a beautiful blue day. But the response is a bell-shaped curve, and as with any light detecting systems, photoreceptors, they may have a wavelength of a color of maximum sensitivity, but they can absorb longer and shorter wavelengths. And if the light is bright enough, it doesn't matter what the color is. And so, yeah, I think one can get also bogged down in blue light. And so companies are selling blue light light boxes, for example, facade and various other things. It doesn't matter what the color is, as long, white light is fine as long as it's bright enough. And what do I mean by bright enough? Well, the studies, and they're probably a bit of an overkill, but 10,000 lux for 30 minutes is very effective at setting the clock, and indeed having other effects as well. Some very nice studies have shown that that kind of light in the morning can more effectively lower levels of depression than things like Prozac. So those photosensitive retinal ganglion cells are probably doing other stuff as well. We know some wonderful studies from the States have shown that they project not just to the master clock, but other areas in the brain, some of them associated with alertness and mood. So they're probably plugged into many important areas of the hypothalamus and thalamus of the brain, which are controlling multiple aspects of our physiology, including mood and alertness.
You have such knowledge on this topic. You can just recite anything.
I'm very old, Mike. I've been around a long time.
So my next question, is there any relationship between sleep disorders and the circadian rhythm?
Yeah, I mean, there's some great stuff there. And we talked about the two drivers, the circadian system, and of course the sleep pressure. So we know that, so if I step back a bit, the molecular clock, how does the circadian system work? Well, there's a bunch of clock genes, and they're turned on. And I should say, this is within an individual cell. So these genes are turned on in an individual cell. They produce their proteins. The proteins form a complex, go into the nucleus and turn off their own genes. Those proteins are then degraded. The genes are then able to make more proteins, and you get a cycle of protein production and degradation. And so you produce an oscillation. And that is the fundamental nature of the circadian oscillator. Now, some lovely work, and one of the first studies, which came from California, looked at familial advanced sleep phase syndrome. So these individuals were going to sleep at around about 7:30 in the evening and waking up about 3-4 o'clock in the morning. And that was associated with a single gene defect, one tiny change in one of those many genes associated with the molecular clockwork. And what happened is that it speeded up the whole clock. And so that affected the sleep-wake cycle. So there are absolutely changes in the clock which can influence sleep-wake timing. But there's also other genes. So we talked about sleep pressure. One of the agents that builds up is called adenosine. That builds up in the brain. And we have adenosine receptors, which in effect can detect what the levels of adenosine are and therefore how tired we are. Now, there's differences in those adenosine receptors. And so if you are very sensitive to adenosine, you'll want to fall asleep early in the evening. And if you're not very sensitive, you can stay awake later in the evening. You know, you need higher levels of adenosine for the sleep to kick in. And so there are going to be changes in the genes associated with both the clock and the sleep pressure. So yeah, it's a really fascinating field.
So what advice would you give to individuals looking to improve their sleep quality and maintain a healthy sleep-wake cycle?
Well, we talked about, first of all, defining, are you getting the sleep that you as an individual need? And that's the first question you should ask. And of course, you know, sleep is incredibly important. If you don't get the sleep you need, then what you see is big changes in our emotional responses. We've talked about irritability, anxiety, loss of empathy, the failure to pick up those social signals from others, a negative salience, which is so cool, which means the tired brain has a tendency to remember negative experiences versus positive ones. So if you're tired, your whole worldview is distorted by your negative recollections. So that's some of our emotional responses. Our cognitive responses, our ability to multitask. And what I mean by that is we are flooded with stuff to do. How can we prioritize? How can we extract what's really important to do now and other stuff can be parked for later? That falls apart when we're tired. And I think we've all experienced that. So memory consolidation, information processing, wonderful data has shown that, you know, sleep hugely enhances our capability to come up with innovative solutions to complex problems. I mean, one of the things that make us human is problem solving. And one of the things that we marginalize is sleep, which is disastrous because then we can't release the full potential of this extraordinary structure that sits on the top of our head. Decision-making, productivity, all that kind of stuff. But the other thing is that long-term sleep and circadian rhythm disruption is associated with cardiovascular disease, altered stress responses, lowered immunity, higher rates of cancer. It's worth bearing in mind that the World Health Organization has designated night shift work as a probable carcinogen because of the high association of colorectal cancer, breast cancer in nurses, for example, night shift nurses, long-term night shift nurses, and prostate cancer in long-haul pilots. Metabolic abnormalities, not least diabetes 2 and obesity. And very importantly, we come back to depression and psychosis and indeed dementia. One terrifying bit of data is we go back to what's the brain doing when we're asleep? Well, it's clearing toxins. One of those toxins is this misfolded protein beta amyloid, which is associated with dementia and Alzheimer's. Well, it's been shown that that is packaged up and got rid of when you're asleep. And if you don't get the sleep you need, you can actually detect higher levels of beta amyloid within the brain. Now, I wouldn't say that poor sleep in the middle years is going to cause dementia in later years, but if you're vulnerable, this could be a risk factor. So it's so important to realize why sleep is important, why we need to define what works for us. And then, okay, if we're not getting the sleep we need, what do we do? And I spend a lot of time, you know, talking about this in the book Lifetime, because I think many people feel, oh, I just get the sleep I get, and they don't have any sense of control over their sleep. But there's so many things we can do. And you can divide activities during the day, before bed, the bedroom itself, and what you're doing in bed. And first thing I would say, one of the key things is, you know, during the day is wind down. Most people don't have a sleep issue or a sleep problem. It's an anxiety or a stress issue, and it's learning to dissipate that stress, during the day, and indeed, if you wake up, how to deal with any anxiety issues. So that's a really important issue, and all the details you can get from the book. Yes, before bed, keep the light levels relatively low. Brighter the light, increased levels of alertness, and that can delay sleep onset. Although I don't think it's going to have much of an effect on the clock, it will impact upon alertness. In our household, avoid discussions of stressful subjects before you go to bed. This is really interesting because, of course, for many couples, life is so busy, when do you actually get time to talk about important stuff? Well, it's when you're lying in bed. But I've actually banned any discussion of family finances or anything that is at all stressful. You've got to make time for it, but the time for it is not when you're trying to get to sleep. So this is kind of obvious stuff. Don't use alcohol or as a sedative. Alcohol and indeed sleeping tablets. Short-term use of sleeping tablets, Zopiclone or whatever, fine. But these do not provide a biological mimic for sleep. They sedate you. They actually reduce the neurotransmitters of alertness. And that can impact upon memory formation and the processing of information. Make sure the bedroom isn't too warm. So part of falling asleep involves a subtle drop in core body temperature. And if you can't experience that drop, then it can be problematic and it's more difficult to get off to sleep. And men and women have a different temperature range, which is interesting. Women tend to want the temperature higher than men on average. And the basis for that isn't absolutely clear, but one argument is that men tend to have more muscle versus fat. Muscle is more metabolically active. And so therefore they're generating more heat. Also, men tend to be bigger than women, so they have a larger surface area to volume, so they'll lose heat more effectively. But that can be an issue. Try and make the bedroom, a place for sleep. Remove the computers, remove all of the stuff. It's really difficult, I know, because of course during lockdown, bedrooms became offices, and you could never then separate the place of sleep and comfort and relaxation from the place of work, and you've got to do that. So if you can, push the device out on a trolley into another room. Try to keep the bedroom for sleep and sex. I mean, just relaxing stuff. Don't clock watch. I mean, many people will have a digital clock and they'll see a glowing green or red, and that can be very disconcerting because if you wake up in the middle of the night, and we'll talk about waking up in a moment, you think, oh my god, I've only got 2 hours before the alarm clock goes off, get stressed, and then not fall back to sleep again. And it doesn't matter how long you've got before the alarm clock goes off. It's when it goes off, and 2 hours is a nice block of time to get some additional sleep. Don't take apps too seriously. None of them have been FDA approved. None of them are endorsed by the sleep organizations. They can provide you with a rough guideline of when you fell asleep and if you woke up and when you finally woke up, but accurate measures of REM versus non-REM and slow wave sleep and stuff like that are not possible at the moment. They will be with AI technology, but we're not there yet. So don't get freaked out. I mean, people have come up to me and said, I'm really worried. I don't get any slow wave sleep. This one person got so anxious about it. They said to me, I set the alarm for 3 o'clock in the morning to check my app to see how much slow wave sleep I've had. That's the kind of the thing you can get into, can get so obsessed with these things. In bed, obviously keep to a routine, both work days and free days. I don't know about in the States. I think you're probably a bit better than the Brits. I think we're a bit cheap about our bedding. I think there's a slight resistance to spending a lot of money on a decent mattress and a good duvet and decent pillows. It's getting better, but get the pillow that makes you feel comfortable, and actually make the bed a haven. You know, it's not just somewhere, it's 30% of our biology is sleep biology. So why not embrace it with a decent duvet or whatever? Consider, now this is an area where I have mixed feelings. So many people swear by, you know, lavender oil or something like that, you know, as a, and I think there's probably a place for some distinctive smell, some pleasant distinctive smell in the bedroom, because then it defines that space as the space where you sleep. And I know many people, if they're traveling, they'll take partner's aftershave or perfume and have a few drops on the pillow, because it reminds them of home, and it's that sense of safety in a strange bedroom, in a hotel. So that could be useful. It might work for you. Now, what about if your partner snores? And this is a really important issue. It's something I talked about quite a lot last year. And I think it started a bit of a revolution, because my point was that as long as your partner's not got obstructive sleep apnea, and for that you need to see, you know, your practitioner. But if it's just snoring or irritating your partner, or you are a morning type and your partner's an evening type or whatever, it's perfectly fine to sleep in another space, in another bedroom. And it's funny, a 25-year-old came up to me after a talk recently and said, "How old do you have to be before you can sleep in a separate room?" Because his partner snored. And so it's no reflection on the relationship. It just means that you'll be less irritable, you'll be more empathetic, you'll have a less negative salience. And I think that it's strange. Many long married couples say, no, it's the beginning of the end if you sleep in separate beds. And I would argue, no, it's the beginning of a new relationship, because you'll be brighter, better, and you can turn it into something special. You know, who's going to bring the cup of tea in the morning, or the cup of coffee, and you know, that sort of thing. And of course, in many societies throughout the world, sleeping, males and females, particularly in Japan, for example, will sleep in separate rooms. And of course, the rich of all societies have slept in separate rooms for hundreds of years. So yeah, I don't be afraid to sleep in a separate room. Oh yes, and the final, I suppose, little snippet that I'd like to mention would be, if you wake in the middle of the night, do not worry. So Roger Eacock at University of West Virginia has done some beautiful work showing from historical records that in the pre-industrial era, sleep for humans was what's called polyphasic or biphasic, which means that you go to sleep, you wake up, you go back to sleep again, and you do this through several cycles at night. Now, with industrialization and a compression of the duration for sleep, we've kind of lost that polyphasic. It's not so clear. But certainly, if you wake up in the middle of the night, it's probably a throwback to our fundamental sleep pattern, which is exhibited by all mammals. And so just stay calm. You may want to leave the sleeping space for 20 minutes, half an hour. You can listen to some relaxing music or whatever. You'll feel tired again and then go back to sleep. It's all about staying chilled and not getting stressed out by it. So yeah, if you wake in the middle of the night, and as many people do, don't worry about it. It was very interesting during COVID, of course, when people didn't have to commute to work. They were saving probably 2 or 3 hours every night, and therefore had an expanded opportunity to sleep. And of course, what was happening is that this expanded opportunity to sleep was associated with waking up in the middle of the night. Then, of course, all the horrors of what we were experiencing, if your business is failing, or if you've got friends, family who contracted this foul virus, you'd worry about that, and it would be more difficult to get sleep. So many people, although they had longer opportunity to sleep, because of the anxiety of that particular time, couldn't get back to sleep. And it's really important not to be anxious about it. One thing I'd also say is it's important to distinguish between sleepiness and fatigue. Sleepiness is cured by getting extra sleep. Fatigue is where you're getting extended sleep, but you're still feeling tired, lethargic, lacking in motivation. And fatigue is often an indicator of an underlying health issue. And so again, if you are getting extended sleep, but you're still feeling fatigued, then go and see a general practitioner. And I was talking to somebody just recently, and they were saying just this. They were sleeping longer, but they just were not feeling refreshed. And we talked about their health status, and what emerged is they'd just been diagnosed with an immune disorder. And of course, that can also lead to health sleep issues. So yeah, and of course, long COVID, as many people experience, a huge fatigue without, even though they're sleeping longer. So do distinguish between the two, and fatigue can be important because it can be an early warning of other sorts of underlying health issues.
So what are your thoughts on people taking melatonin or magnesium?
Well, if we deal with magnesium first, there is some evidence suggesting that magnesium can improve sleep. It's not great, but it's emerging. Melatonin has been overhyped, as so many of these things are. Melatonin is a mild modulator of sleep. In the best studies that have been published, taking melatonin at nighttime before bedtime can reduce the time it takes to get to sleep by about 20 minutes or so. Can't keep you asleep. And in some studies, it's had no effect at all. So yeah, it's a mild modulator, but it is emphatically not a sleep hormone. People who are on beta blockers, for example, can't produce much melatonin, and their sleep-wake is broadly ineffective. And interestingly, supplementary melatonin in those individuals doesn't really help, which is intriguing too. Individuals who were quadriplegic, so they'd severed the nerves of the sympathetic nervous system, which were regulating the pineal. They don't produce any pineal melatonin, and they were reported to have appalling sleep. And then somebody compared those quadriplegic individuals with paraplegic individuals who are paralyzed from the waist down, not the neck down, and they had just as bad sleep. So it's a feature of paralysis of some form, not the lack of melatonin. What we know about melatonin is that in seasonally breeding mammals, such as deer, sheep, and whatever, the melatonin reflects the duration of the night. So as the seasons expand and contract, and it's reflected in the duration of melatonin release. And so the shortening day lengths, the increasing night lengths in the fall is picked up by deer, for example, and other big mammals. And that will trigger breeding, so that you then have the development of the young throughout the winter months, and they pop out in the spring when there's plenty of grass to sustain milk production in their mums and weaning. And so that's a very clear role for melatonin. Do we show an expanding and contracting melatonin pattern? In agricultural workers, this has been done, and it does seem to be the case. Those individuals exposed to the natural light-dark cycle. Does this seem to affect human reproduction? We don't think it does. No, there's no good data suggesting that. So melatonin is not a sleep hormone. It's a mild modulator of sleep. And it can, in some people, reduce the time it takes to get to sleep. But, you know, I think there are other ways in which you can, it's probably having a big placebo effect as well.
Yeah, my girlfriend takes it all the time, and I'm like, how do you even know if you could sleep without it?
Yeah. Well, I think that's it. I mean, it's very interesting that we always, as a species, default to either an app to tell us whether we've slept badly or not, or a drug to change our sleep in a way we want. When, after all, we've been sleeping naturally for a very long period of time, and we just need to revert to those sorts of patterns without. I mean, clearly, drugs are important under certain circumstances, but they shouldn't be the first thing you go to.
So you talked about shift work a little bit earlier, people that work overnights. Are there any ways people can minimize the impact of having that on their bodies?
I think that is a really important point. And I think it raises the issue, which is we're in a 24/7 society. It's not going to change. It would be naive, stupid to say, don't do night shift work. We're going to need our police, our firefighters, our healthcare workers, all the rest of it. I don't think we necessarily need to embrace the 24 society to the extent that we do. We could perhaps make it a bit easier for workers, but nevertheless, it's here and it's not going to go away. So the key thing is, what can we do to mitigate some of the problems? So driving home after the night shift. So a study from the UK showed that 57% of junior doctors after the night shift had either had a crash or a near miss driving home. And that's common in other groups. So what do you do? Well, of course, many cars now are being built with nod detectors, and whether you're falling asleep or whether the car is drifting off. If you don't have that built in your car already, and most people don't yet, then you can get an app which you can put onto the dashboard, which will tell you whether you're doing that. That should be made available by an employer for an employee with those individuals doing regular night shift work. Poor mental and physical health, as we've touched on, then high frequency health checks to try and catch these issues before they become chronic and then more difficult to deal with. So higher rates of diabetes too in night shift workers. So simple to do a glucose test, and if they're borderline, then you need to kick in those corrective measures. So higher frequency health checks is something that's easy. High levels of obesity, diabetes 2, metabolic abnormalities. What food do we make available to our night shift workers? It's high fat, it's high sugar, it's vending machines full of chocolate sugar bars. And it baffles me why nobody has produced a high protein, easy to digest snack, which we can give to our night shift workers throughout the night. At least it's an option. And that needs to be coupled with education, because the problem is, if you're tired, you crave carbohydrates and you crave sugars. But knowing that that's what's going on, you need to make an active choice not to take those which will impact upon your metabolism, and choose a healthy alternative. Education generally, night shift workers need to know what they're letting themselves in for, but also education for the people they live their lives with. In some sectors in the States, night shift work is associated with a 6-fold greater divorce rate than the same job on the day shift. And so partners need to be aware that this is not your partner becoming a monster. It's that this is an inevitable consequence of driving physiology way outside of its normal range. They can't help it often. So you've got to work out a way to resolve these changed behaviors, how you adapt to it. The other thing that I think is important, and we don't have good data for this, but it's something I'm really keen that somebody looks at, is that these pathologies get worse over time. And so what if we limited night shift work to 4 or 5 years, then you reverted to the day shift? And do you completely unwind some of those health issues that we were talking about earlier? And it's not clear. But I think there's now enough scientific evidence where employers, employees, and the government and scientists need to sit down and say, okay, what can we do now in the workplace, showing a proper duty of care for this essentially vulnerable group of workers? Now, the other thing, of course, to raise is that most people don't like to do night shift work. And so they do it for economic reasons. And so it's individuals from a lower socioeconomic group, often, not completely. We've just completed some studies on the banking sector and night shift in the banking sector. But these most individuals are blue collar and they don't have a voice. And so their needs are not being fully listened to. While we're on the topic of socioeconomic, we did a study a few years ago on early adolescence. And we asked them, did you share your bedroom, your sleeping space, with anybody else? Does different age groups, affect sleep? What we didn't ask is, do you have a bed? And what became clear in kids from a lower socioeconomic group is that they didn't have a bed. They were sleeping on the family sofa, or the family were watching telly. And so they were getting really awful sleep. They were going to school the next day, sleep deprived, So they couldn't make full advantage of their educational opportunities. So in a sense, they were already being marginalized because of the poor sleep conditions. And I don't think we fully appreciated the impact of poor sleep on our young people and their ultimate educational and life trajectories.
So, are there any recent breakthroughs or advancements in sleep research that you find interesting?
Well, I think generally the field is I've been in it almost from with the early meetings were 80 people or 100 people, tiny by today's standards, where we've got huge numbers of people attending these meetings. And the drift, though, has been, first of all, that circadian researchers and sleep researchers talk to each other, which they didn't do in the past. And so it's really great because we're now understanding the fundamental interactions between the circadian system and the sleep systems, and understanding that biology. I think that's exciting. I think another area is that, okay, so we've got this master clock within the brain, the suprachiasmatic nuclei. It consists of 50,000 cells. But what are each of those cells doing? They're expressing different genes, they're expressing different proteins. So, for example, we know that females, women, will adapt to jet lag faster than men. What the heck is going on there? And we've identified estrogen receptors in the master clock, which we think are modifying the clock's signals about adapting to the new light-dark cycle. And so we're beginning to get some cellular understanding, not just this is the clock, this blob of cells, but actually how those cells are interacting at a cellular and subcellular way, which I think is amazing, and it really is a great model to understand how genes producing proteins can interact to produce complicated behavior. So model systems. So any potential neuroscientists out there, think of the circadian system as a brilliant model to understand fundamental mechanisms. And I suppose the third area would be that we're using this fundamental knowledge to develop new drugs, new therapeutics, to improve the quality of life and indeed educational opportunities of many people across the world. We talked about the blind and mental health and the new drugs we're developing. We're not the only people. There are other groups looking at those drugs, different sorts of drugs. So, for example, we know that some studies have shown that in cancer cells, which divide very rapidly, repeatedly, if you put a circadian clock back in those cancer cells, they stop dividing in this unrestricted way. So could we put a clock back in cancer cells and stop the unrestricted cell division? These are sorts of really exciting stuff on the horizon, and friends and colleagues across the world are thinking of ways of using circadian knowledge and circadian biology to try and improve human health and performance.
Are there any last remarks you want to add?
No, I just think it's an exciting time to be in this part of research. I mean, we, in the early days, were reporting phenomenology, 24-hour behavior, and we had very little understanding. We now have a key understanding of centers within the brain that are driving this stuff, and the cells within those centers within the brain and how they work. So I think it's been, for me at least, an extraordinarily exciting journey, and it's not over. I mean, the individuals that got the Nobel Prize in 2017, Hall, Rosbach, and Young, people I knew when I was in the States, they got the Nobel for understanding the fundamental mechanisms of how the molecular mechanisms, how the clock works in flies. And in the citation, our understanding could have big impacts upon human health, but this is yet something that has yet been the potential of this has yet been fulfilled. So I think we've got this stuff there, and now we need to attract researchers from all the health disciplines to think about circadian knowledge, how it impacts upon their systems, and what that can be used for. So, the timing of drugs. Take anti-cancer drugs for example, at different times, they have different effects. How is that being embedded into medicine? Taking antihypertensives at different times can have long-term effects on stroke. So there's also what's called chronopharmacology, another, I think, incredibly important area where we can time drugs so that they can have their best effects during a narrow window of time. So there's a heck of a lot to do. There's lots of tools and there's lots of fundamental knowledge that we now need to apply.
So if people want to get a hold of you or your research, where can they go to?
Go to the Sleep and Circadian Neuroscience Institute website. And if you just do a Google on me, Oxford University, Russel Foster, you can pick up my email, and I will do my very best to get back to you with a response. It may take a while, but I will do my very best to respond to your emails.
Well, thank you so much for joining us today.
Really great to chat, Mike.